Hey everyone, in this video, let's take a look at perimeter and area in the coordinate plane. So the first thing we should do is take a look at some of our basic formulas for perimeter and area. Let's look at the formulas for just our basic shapes. So let's start with a triangle. All right, on the triangle, the way that we label our side lengths are normally just A, B, and C, using three different variables to represent that the three sides may have different lengths. Our perimeter is just the distance around the shape. So we are just adding up all the side lengths. For some shapes, we have some shortcuts, but for a triangle, it's just A plus B plus C. For the area of a triangle, the formula for area is 1/2 base times height. Now, the important thing here is the height of the triangle has to be perpendicular to the base. So if this is the bottom of my triangle, the height of this triangle is from the very top straight down to that base. So if I drop a segment straight down and it forms a right angle, that's my height. Okay, let's take a look at a square next. So a square, the one thing we know about this is all four sides are the same. And we also have four right angles. And all four sides are the same, so let's just call one of these S for side length. Okay, so the perimeter for this is all the side lengths added together. So that would be S plus S plus S plus S. So we have four of them. So this is just the same as 4 times S. The area of a square is its length times its width. So in this case, it's just going to be S times S. Another way to write that is S squared. And the last basic shape I want to take a look at is a rectangle. So a rectangle also has right angles, but now we have two sets of sides that are congruent. So the left and the right are the same, and the top and the bottom are the same. And then let's just call this the length and the width. So the perimeter, again, it's just adding up all the sides. So we have length plus a width plus a length plus a width. We have two lengths and two widths. So we can shorten that up into 2 times L plus 2 times W. And then the area of a rectangle is length times width. Now that we have these formulas established, we can use them in the coordinate plane. So let's take a look at that. So I'm given 3 points here. I want to graph these, and then I want to find the area and the perimeter of this triangle. So let's start by graphing this. So the first point, -2, 3. My x value is -2. My y value is 3. So I start from the origin, and then I do my x value first. So I'm going to do -2 in the x direction. So this is my x-axis. This is the y-axis. So starting here, we go 1, 2, and then my y value is a +3. So then I go 1, 2, 3. So that's point A. B is the point 3, 3. So again, we start at the origin, and then we do our x direction first. So 1, 2, 3. And then now my y value is -3, so I'm going to go down 1, 2, 3. So here's point B. And then our last point C is -2, -3. So we go -2 in the x, -3 in the y. So there's our 3 points. I'll connect these together to make a triangle. Okay, so here's our triangle. Now, one thing I note right away is I have a vertical segment and I have a horizontal segment. So this is actually a right triangle. So we have a right angle right here. So I need to find the area, I need to know what my side lengths are. So I need to know what A, B, and C are. Two of the side lengths are really easy to find. Because they are horizontal or vertical, we can just count how long they are. So this side over here, AC, this is 1, 2, 3, 4, 5. This is 6 units long. The length from B to C, again, we can just count that. 1, 2, 3, 4, 5. So that takes care of two of the sides. To find the last one, well, it's a little slanted, so we can't just count it, but we can use the Pythagorean theorem. So again, the Pythagorean theorem, a squared plus b squared is c squared. We know the two legs, so we know 5 squared and 6 squared, and that's going to give us our last side length squared. That's going to give us our hypotenuse. Remember, the hypotenuse is always the side that's across from the right angle. So 5 squared is 25, 6 squared is 36, 25 and 36, that's equal to 61. So that means that this side length, taking the square root of both sides, we get the square root of 61. Okay. So now that we have that taken care of, we can find our perimeter. So the perimeter, we'll just add all of those up. So we have 5 plus 6 plus the square root of 61. If I combine like terms, I get 11 plus the square root of 61, which would be an exact value. But let's say we wanted to round this a little bit. So if I do 11 plus the square root of 61, we end up with about 18.8 units. All right, now let's find the area of this. So area is going to be equal to 1/2 base times height. Now remember, I said the really important thing about the height is it has to be perpendicular to the base. Well, this is a right triangle, so I already have a right angle here. So let's say our base is 5, then that would mean the height is 6. So our area is equal to 1/2 5 times 6. 5 times 6, that's 30. So 1/2 times 30, we get an area of 15 units squared. All right, let's try one more. It's another triangle, but in this case, it's going to look a little bit different. So I'll plot my 3 points right away. Okay, so here's our triangle. And again, the first thing we want to do, let's find our perimeter. So adding up our 3 sides. We have one vertical side this time, so we can count to see how long that is. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units long. And to find our other 2 sides, they are slanted, so we are going to have to put in a little bit of work. I could use the Pythagorean theorem again, or I could use the distance formula. Either way works. I'm just going to use the Pythagorean theorem. So I'm going to draw in a little right triangle. And then I'm going to take a look at to see how long these sides are. So 1, 2, 3. So this is 4. And then over here we have 1, 2, and 3. I'm going to do the same thing for our other segment here. So drawing in the right triangle just to see how long the sides are. Here we have 1, 2, and 3. And then our vertical one, 1, 2, 3, 4, 5, 6. Okay, now let's plug those into the Pythagorean theorem to find the length. So for the first one, we have 3 squared plus 4 squared is equal to the hypotenuse squared. So this is 9 plus 16. which is 25. And the square root of 25, that actually works out, so we just get 5. So this side length here, this one has a length of 5. And to quickly do that for the second one, 3 squared plus 6 squared, that's equal to the hypotenuse squared. That's 9 plus 36. 9 and 36 is 45. So then our last one, we get the square root of 45 as our side length. That one's not a perfect square, so it doesn't simplify as nice. So I'm just going to leave it as the square root of 45. Okay, now that we have that, we can find our perimeter. We'll add up the 3 sides. So we have 10 plus the first one we found, which is 5, plus the second one here of the square root of 45. Combining like terms, we get 15 plus the square root of 45, which again, this is an exact answer. But if we wanted to round this, we end up with an answer that is approximately 21.7 units. And lastly, let's find the area. So area is 1/2 base times height. And just as one more reminder, the height has to be perpendicular to the base. So if I look at my side lengths here, I don't have any that are perpendicular to each other. So what I'm going to do is I'm going to pick out the easiest one, the easiest side length to find the height that's related to it. So because this side length EF is vertical, I know that the height would have to be horizontal. And horizontal segments are really easy to work with. So from this very far point, I want to go straight across to my base. Straight across to that side length of 10. That's going to form a right angle. And then this segment, that's going to be my height. It's orientated a little bit different than we're used to seeing, but that's okay, as long as it forms that right angle. And also, because it's horizontal, we can just count to see how long it is. 1, 2, 3. So our height is 3. So now our area is 1/2. Our base we said was 10, and then our height is 3. So that's going to be 1/2. 10 times 3 is 30. So we end up with an area of 15 square units.